In this section, we're going to be talking about reading a Table 1. And so Table 1 is essentially a keyword that often indicates more than just the first table in a manuscript. A Table 1 often includes information about the sample at baseline or before the study has begun. And this information helps us further assess the internal and external validity of a study. So after a target population is selected and a sample is taken, they're allocated to exposure, so exposure or treatment groups, and then those individuals are described via a Table 1. So let's revisit that clothes trial again. And so recall that in this trial, we're looking at silk garments plus standard of care compared to standard of care only for treating eczema in children. You can find the full article in PLOS Medicine. So here's the top of their Table 1. And so there's a couple of key pieces of information to highlight here. So just notice that we've got the standard of care group and the intervention group, as well as the total. And we've got different values for each of those. So first here, the sample size for the baseline sample is included. So 151 for the standard of care group, 149 for the intervention, which equals 300 total. So recall from the reading a flowchart section that these numbers correspond to the number that were allocated after randomization. So some of these patients were later lost to follow-up. A Table 1 typically includes baseline data, so patients that are included in a Table 1 might not necessarily be included in the final analysis, but they give an idea for kind of how that initial cohort, what they looked like. Okay, so the next portion to consider is this far left column, which this usually includes patient characteristics. And so these are typically demographics and clinical characteristics that were collected at baseline for these patients. And this list may include potential confounders. So recall that confounders are essentially when there's a relationship between two variables, like an exposure and outcome, and it's distorted by some third variable, so some confounder. So in this study, the two variables here would be silk garments, the exposure or the intervention, and then eczema, the outcome. And that third variable or variables could be a list, it could be from this list of characteristics that were assessed in the Table 1. For example, age might be one of them. And now in this particular study, because we're dealing with a randomized control trial, there's less of a potential for confounding. So we'll be talking a little bit more about that in the subsequent sessions about, in which cases we're really worried about confounders. But these baseline characteristics kind of give us an idea of what was measured. And observational studies can be really key to look at for confounding. Okay, so finally, now here are the actual values. I've put a little box around them in that Table 1. And what we're assessing by looking at these values usually is balance. And so what I mean by that is how evenly distributed these characteristics are across treatment groups. And so depending on the variable type, the values that are reported are going to be a little bit different. So in the previous section, we talked about different types of variables, how they can be either continuous or categorical. And so for continuous characteristics like age, for example, the values that are going to be reported are the mean, the standard deviation, often abbreviated like it is here as SD, the median, the interquartile range, which would be the 25th percentile and the 75th percentile, and the minimum and maximum. And so I'm going to kind of walk through each of those mean very briefly, and then we'll come back and talk about categorical variables. So here's an example of a continuous variable. I've plotted the values of this variable horizontally. So my sample size in this example is 21. So I've got 21 dots here, each corresponding to the value of this continuous variable that I've created. And so the mean here is going to be the average point. So it's the value we would get if we added up the value of each point and divided by the total number, so 21. So this falls kind of where we would think it would, kind of based on where these points are. The standard deviation is a measure of spread. So for example, here in blue, I've highlighted one standard deviation above the mean. And now I can also look at one standard deviation below the mean. So we're going to get into the nitty-gritty, the specifics of what standard deviation is in the measures of association section, but this is just to kind of demonstrate that standard deviation is some measure of spread. It lets you know how spread out your data points are. Okay, the median is the middle point. And so here, because I have 21 dots that I've drawn in my continuous variable, my sample size is 21. After picking that median or that middle point, I'm going to have 10 points that fall above it and 10 points that fall below it. So the median is the middle point in your data. The 25th percentile is the point that splits the data such that 25% fall below that point and 75% fall above it. And similarly, the 75th percentile is the point that splits the data such that 75% fall below the point and 25% fall above it. And that region from the 25th percentile to the 75th percentile that we discussed is the interquartile range. And then the minimum is just exactly as you would expect. It's the smallest point. The maximum is the largest point. Okay, so that's what those values are. And all of these summary values, they help us understand the distribution or the shape of the data. We're going to see this more clearly when we're discussing statistical graphics. But understanding these summary values can basically help you assess the population that the sample is drawn from, as well as assess that balance between treatment groups. And that's important because we want to make sure we're making a fair comparison between the two treatment groups. And so making sure that they're balanced on these characteristics can help us understand whether there's a fair comparison. For example, here we're looking at age. And so if we were doing a study where everybody given the intervention was much, much older than everybody given the standard care, that might influence our final result. And we'd want to understand that relationship. Here it looks like that they're very balanced on age, because you can see that the mean is 5. So the mean age in the standard care is 5. The mean age in the intervention is 5.1. Those are pretty similar. So it looks like they're pretty balanced. And similarly, the median is pretty balanced, 4 and 4. And the minimum and maximum, they both have a minimum of 1. And the intervention has a maximum of 15, but pretty close to that standard care of 14. So for categorical variables, they're going to usually give you the counts and percentages for each group. And so these also are used to help understand the population from which the data was drawn. And so, looking at the balance here, we can see that boys versus girls, there were slightly more boys in the intervention group than in the standard care group, so 62% versus 54%. But overall, there is not some really dramatic difference between the two. And so that can be important, because if gender plays a role in how your outcome or eczema looks, then it might be important to understand whether or not these are balanced on gender prior to the intervention.